Good morning. How are you doing this morning? And welcome. If you haven't been in one of my classes before, let me introduce myself. My name is Alex Cooper. I teach the computer classes at the Columbia County Library in Evans, the Harlem Library, Uchi Creek, now our Grovetown Library because we have a new library. Yay! Very glad that you're here with me today. So this is a very special class. These are Raspberry Pi projects with Alex. That's me. So basically, it's kind of more of a free form of we'll pick a project and then we'll work on it so that we can actually learn a little bit more about our Raspberry Pi. And we're going to teach a little bit about using our Raspberry Pi, and I'll have a handout that you can download too from our Raspberry Pi physical computing class and Python code. Okay. So as anybody comes to the class, I'll say welcome. Very glad that you're here today. And let me go ahead and go into, if you have any questions, let me know. I'll definitely be talking about everything that I have and listing, of course, some help if you want to start working on some of your own Raspberry Pi projects as well. Definitely feel free. So how can I help? Have any questions? How can I help? Okay. Happy to help in any way. Especially answer any questions that you might have. I think I've just said that twice. Sorry. All right, so let's go ahead and let's talk about some of the other classes that we have coming up. So this afternoon we actually have internet safety and security will be going on at 2:30 here on the Columbia County Library, Harlem Library, and Uchi Creek now, of course, our Grovetown Library YouTube channel. If I can say the right thing, that's funny. So next week we'll be doing some fun classes too. On the 10th, we're kind of gonna getting started gearing up. Of course, it's the November, so we're thinking about Thanksgiving and gifts for stuff for the holidays and everything. So we got photography, printing, and virtual scrapbooking. So that could be a great holiday gift. On the 11th, we're doing a gadget help on Facebook Live on the Harlem Facebook page, so come join me for that. And then we'll be doing another Raspberry Pi projects with Alex, that's me, on the 11th in the afternoon. And then the 12th we'll be doing a Let's Talk About Libby, free ebooks, digital audiobooks, and other resources. Okay, and then that afternoon we're going to be doing app swap. I'll be talking about apps that I really enjoy. It helps me every day, and then you can come and tell you about apps that you enjoy as well. Because it is near Thanksgiving, we'll be doing some Scratch classes that include some fun Thanksgiving stuff. Scratch, let's make a turkey feather catch game. And Scratch, let's draw and animate a turkey. So come join me for those as well. Just a little side note, our library has switched over from RB Digital to Libby. So do realize if you are looking for free audiobooks, free ebooks, all you need to do is download the Libby app. If you have your library card, all you need to do is type in, don't search for Columbia County Library, Harlem Library, Uchi Creek, or Grovetown Library. Just type in Greater Clarksville Regional Library System, and then it'll pop up, and then click where it says Georgia Download Destinations. Enter your library code, and then, your library card number, library code, and then you'll actually be have access, and you'll be in. Okay. Our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details or call the library questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel. We're having a subscribe drive. If we can get 100 subscribers to our YouTube channel, we'll actually get our own customized YouTube address. Or you can search YouTube for GCHRL videos and it'll pop right up. All right, so let's go ahead and get started this morning. So what I want to do first is I want to post the handout. I'm going to it a little bit. Okay. So basically we do a class where everybody has like a Raspberry Pi, okay, a little Raspberry Pi computer, And the big thing about that is we all have one, and then we're all working on the different projects together. And this is the handout I will give everybody. This is kind of an overview. It's kind of an all-day project. Raspberry Pi and physical computing. So let me open that real quick too. It's loading. All right, so this is, I'll pull it over here. This is what we use in our classes when we do our Raspberry Pi and physical computing classes. And it kind of has a brief overview to kind of get you started with the Raspberry Pi. If you haven't used the Raspberry Pi before, here's a little Raspberry Pi there. And basically this whole handout basically gets you started, lets you know a lot of information about it, and also talks about coding, a LED, coding, introduction to Python a little bit, okay? Getting started with Python, a big one, and it allows you to make a reflex game. And we always need to remember, first attempt in learning is usually fail, okay? So do realize that. You put it together, it's not going to work first time at least, second time, third time, maybe fourth time it'll work, hopefully. So that's just what happens. First attempt in learning is fail, so let's remember that. So we have our little Raspberry Pi here. This one actually talks about the Raspberry Pi 3. They've actually come out with the 4, and I will get out of the way here. All right, so you need a computer, just an old computer monitor, USB keyboard and mouse. You need what's known as a breadboard. We'll talk about that more in just a second. And for these, that's a little different than the project we're going to be doing today, which I'll talk about what we need for that in just a minute. It lists the projects that are on the handout, I guess you'd say. So you have your Raspberry Pi. Here's your breadboard right here. You need your different wires. Depending on what project you're working on, you need different, here's a button, here's the LED, here's some resistors. And then it kind of talks about using Python a little bit. Okay. Now the Python we're actually going to be using today will be Muse. And I'm going to go ahead and show you. Now, earlier in I'll move that. Earlier in October. Yay, okay. Yay. In October, we actually did a few projects, and one of them was making a sound, a step sound. So if someone steps on it, it would make some noises, okay? So here's our Raspberry Pi. That's actually still hooked up and everything. So I'm going to go ahead and plug that in. We'll remove that. Let me turn on another light because it's dim in here. There we go. That should help a little bit. Okay, so we have our little Raspberry Pi here. We unplug the here's our Raspberry Pi. We have the Raspberry OS installed on here. We have an HDMI out. We have our plug-in for power. We have our headphone jack. Okay. We have 4 USB ports here. And then, of course, we have our Gpio pins, which are right here. Okay. I'm going to go ahead and plug it in and give it power. I've actually preset this to be able to connect with it wirelessly. So we can have it on the monitor. Whoop. Helps if you plug it in the right way. All right, so give that a minute to load, and then we'll connect to it. Alright, so we're going to connect to our Raspberry Pi now. Yay. And here we are right here. Okay, so we're connected to our Raspberry Pi. Let me move it over here. So let's see what we can do. Now I'm actually connected to it through the wireless. And if you're wondering what I'm doing, it's called VNC server. You can look it up and it's very easy to do. So we're all connected to the same network. Okay. All right. So if I actually click here, and then we can go to programming, and you'll see me on here, MU. And I'll turn off the camera for now. And this is actually the way we're going to be doing our coding. Last time we did a breathing LED, which is pretty neat. All right, so we do new, and it puts it right here, okay? So let's go right ahead, and we're actually going to do our little bit of introduction code, kind of our classic hello world, okay? We're going to do print. Have to save their file, so we'll just call it, I'll just call it test for now, and then we'll say run. Did I already call it that? Okay. Call it test 2. How about that? All right, and then I hit run, and then boom, at the bottom it's actually going to pop up and show it. So instead of in a separate shell, we're right in the shell and in the editor. It's actually all right here with Mu, and Mu, we won't be using it today, but Mu does already have Python game or Pygame built in, okay? All right, so basically how we do our file system and everything. All right, now let's minimize that, and let's talk about our Gpio pins, okay? So with our Raspberry Pi, we have our Gpio pins that stick out. And repeat after me, general input output. That's right. General input output. Our pins actually have a bunch of different settings, but mostly there are just these 3 right here, okay? One will give off about 3.3 volts of power. Another will give off 5 volts of power. We have a bunch of ground ones, okay? And then we have some general purpose ones. GP, whatever the number is, okay? And if we look at the bottom here, we can actually see our general input output pins, okay? Now, I don't actually have one of the little topper things here that actually registers it. I actually do have this chart, and I also have a chart that came with my Raspberry Pi. Whoops, it's upside down. With my Raspberry Pi from Kana Kit, so we'll be using that as well with our projects. So I'll kind of have that sitting out there to make sure that we're using the right GP number and everything. Okay. All right. So you'll see 3 volts, 5 volts, or 3.3 volts. general purpose, and you'll see ground as well. Okay, are these in number order? No, they are not. I believe the last code I did with this this project PDF that came with our little kit with our other stuff in it actually does use a setting that makes it have numbers on here, just regular 1, 2, 3, 4, 5, 6, and the handout that I have actually shows that as well. So they call it pin board numbers, so don't let that confuse you, okay? So we'll be talking about that too. So there's a way to number the pins in order if you wanted to, and I believe our handout will probably do that. So let's talk about our general input output, and then we'll start off with our project. Basically, the main thing is that when we actually create a circuit, we need to have our positive, okay, and we need to have our negative connection, which is our ground, okay. So this would be like our general purpose plug, or plugged right into the power, goes through the LED. Electricity only flows one way through an LED. We have our resistor or fuse, okay, to make sure that LED does not get too much power. Goes through here. If the circuit is open, there's no electricity flows through. If it closes the circuit, it goes back to ground. So why do we need to know this? So we need to connect to our pins that'll give it power, or the general purpose pins that we can control it with, but we always have to make sure that our stuff is connected to the ground to complete a circuit, okay? So here's kind of a tactile button that we have, and this is talking about our breadboard that we're going to be using. Big thing about our breadboard is this kind of has it split off, and I always want to show this. There's rails, okay, so you can plug something in here at the top of the rail and then have something else down here, and they'll connect. But if you use this like a vertical rail, and these are like the horizontal rails, and then there's like a river in the middle, so there's nothing that connects from one to the other, okay. But these rows here is where you plug in something here on the same row, plug in something here with the different, you know, holes there, and then they'll be connected, okay? So instead of us having to solder wires together, we're going to use our classic little breadboard for our projects, okay? So projects with no soldering required. Yay. All right, so let's go ahead and we'll jump into our project here. And this is the actual handout that comes with the little kit that we purchased, and I'll show that real quick. This is what we made last time, and I haven't actually taken it apart since the last time we worked, but this was the doorbell project we did, which is still up and available as well. And what we're using is, this is actually all based on the free Novi kits. I purchased this off of Amazon. It really wasn't very expensive. I think it was like 35 or 45, something like that. And this is the free Novi RFID starter kit, okay? And it actually tells you where you can go and, you know, download the projects and stuff. So all this is still free on their website. Of course, you have to have the kit to be able to make stuff, which makes sense. So we have lots of great stuff in our little kit, and we're just kind of going through with our little projects because they all gave us a whole bunch of components here. And the big thing is a lot of them do have very specific tasks, so we have to make sure they're not being bent in any way. We put it back in our kit, okay? So let's go ahead and let's pull up. So this is on their website. You can download this. The free Novi website. I don't have a direct link for that. It just says free Novi, FREENOV.com/FNK0025, okay? And tutorials are tutorialfreenovi.com, okay? So this is all stuff that they have free on their website, okay? So I'll kind of skip through here pretty quickly. So it's listing projects. It has a nice introduction. I will say it's not as friendly as maybe a Raspberry Pi project that we do a lot from the Raspberry Pi website, but this is getting more into working with more components than that what they discussed. I've got a little joystick in there too. Thought about doing that project today, but I do know that I want to get ready because I want to know about this RBG LED multicolor light. Okay, so it's actually I've already done the LED blinking on previous ones. There's a LED bar graph one. If we have time, we might mess around with that. We did the breathing LED. Okay. We also, and this is one we did our buzzer. That's on here too. And we did the RGB LED, which is this one here. And they have all kinds of different ones. And the next one we might deal with is the photoresistor and the joystick, or we might jump into motors. We'll see. That would be kind of interesting. If I don't have the motor connected to anything or anything connected to the motor, I'm not really sure what the project would be, but to just learn how to control the different types of motors, motor, servo, or step motor as well. Okay. All right. So I think it's not exactly 88, but let's go ahead and let's get started. And hang on, I gotta find it. All right, there we go. So that's what we want our project to be today. It's going to talk about an RBG LED LED. Okay. So I kind of had an idea that this could be turned into kind of like a Christmas project that we did in December, and not just me free-forming creating something, but an actual possible Christmas project, making something. And I'll have to look into that a little bit more, but let's go ahead and we'll get started. Let's read about it. Okay, so RGB LED, and I will turn off my camera for now. Here we go. RGB LED. In this chapter, we will learn how to control RGB LED. A RGB LED has 3 LEDs integrated into one LED component. It can respectively emit red, green, and blue light. In order to do this, it requires 4 pins. This is also how you identify it. The long pin is the common, which is the cathode or positive LED, the positive lead. No, it's lead. Ugh. The other 3 are anodes or negative leads. A rendering of RGB LED and its electronic symbol are shown below. We can make RGB LED emit various colors of light and brightness by controlling the 3 anodes. So basically showing it right there. And let me look through my thing here. There it is. Oh, sorry. Camera was not on. All right, so I'm just kind of looking through my little box of goodies here. So here's kind of the stuff I got. It's going to give power. That looks like that's one that actually goes with the step motor or the motor. This one is an LED matrix is what they call it. A lot of wiring going on for that one. I can tell you that. I've already looked at that one. And let's see. There's a step motor right there. I think this one we kind of associate with electronic, you know, doing wheels and stuff. And where is there's the joystick. And right in here I actually have the RGB LED. Okay. Here it is. Here's the servo one. So this actually controls, you can control what angle a motor is at. So learning more about electronics too. And here's our little keypad. Do, 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 do. Some input. Okay, so put everything back. And I think I'll need this chart a little bit later. So got our wires and everything. So for another day. Projects for another day. Alright, so let me go ahead and get, and I probably need a bunch of LEDs in here and little buttons, but there's our RGB LED. RGB LED. Okay. All right, red, green, and blue light are called three primary colors. When discussing light, note for pigments such as paints and three primary colors are red, blue, and yellow. When you combine these three primary colors of light with the varied brightness, they can produce almost any color of visible light. Computer screens, single pixels of cell phone screens, neon lamps, etc. can all produce millions of colors due to, I don't even try that, phenomenon. I don't think that's what that word is, but we'll say later. If we use a 3-bit PWM, which is what we did with the breathing LED, to control the RGB LED in theory, we can create 16 million colors through different combinations of RGB light brightness. Next, we will use RGB light LED to make a multicolor LED. Okay, so what we need for our project, of course, we need our breadboard wired up as well. We need our jumper wires, which we have plenty of those. One RGB LED, and we need a 220. We need 3 220 resistors. Okay, so the real challenge, the real challenge. Now, because I've actually taken some of the resistors out and used it for the previous project, this is actually a chart telling us which. Let's see. Oh, there we go. That's a much more complicated chart. Alright, so this is actually supposed to tell us which ones are which. So let's see if we can. Oh, I know what I need. Yeah, I think that's a 220 right there. And if I remember, let's see. Yeah, I think so. I think the top two here were 220s, and then this one, I know they weren't all the same. Let's see. Well, black. This must be the 1K, I think. Oh. Hang on a second. I've left something in the room. I'll grab it real quick. All right. All right, that's a lot better. Okay, so like light brown, black, black, red, and red. So that's a 1K. I'll go ahead and put that back with that. All right, we need another 2. 220. There we go. Let's see. I probably should get some little bags and then mark those. I think that would probably be a little bit better. But with our other project, we usually use the 220s. So okay. So we need one more of those. Okay. I'll take from this group, I guess. That one will break up the band. All right. Sure here. Okay, brown, red, black, black, yep. Brown, oops. That one around. Brown, red, black, black, yep. Black. Yep. Okay, so we're good to go. All right, now we got our resistors. Let's go ahead and scroll down. Let's talk about our circuitry. Now, of course, they give us a traditional schematic here, but we're going to go down to this one, of course. So what that means is we need to take all our components off of our previous project, and let me see. So we're going to put them in our box for next time. Okay. All right, so look and see what we got going on. So this is what we need to wire up, okay, and then it's going to explain it, okay. So let's go down here and let's talk about what we're going to be doing. In this kit, the RGB LED is common anode, The voltage difference between LED will make it work. There is no visible ground. Ooh, interesting. The GPIO ports can also receive current while in output mode. If circuit above doesn't work, the RGB LED may be common cathode. Please try following wiring. There is no need to modify code for random color. Okay, so this is if I, alright, so the ground. Okay, so I guess this is the way we wire it up, and then we do our code and we'll see what happens, okay? So if this doesn't work for some reason, then we'll do this one, but this is the one that came with the box. So I assume that that would be the one that they would want to do, okay? All right, so let's get it all set up here. All right, so we have our, whoop. Now it does actually look like this length of the, I guess the legs, we'll say the legs are a little different. And I don't see where it's showing us well, that's interesting. Does it matter? It probably does at some point. I don't know. So we will see. It may not matter because of what happens later. We control and see what each one does. Okay, so this is the C code, and let's go down to our Python code. First observe the project results and then learn about the code in detail, okay? And it's just telling us where the project is. So one good thing about these kits in general is that, or you download it from the website, it actually has the code, okay? So, but of course we're going to type it in, but we could just open it if we wanted to, but we want to do the code by hand so we know a little bit more. But if it gets too long, I can copy it over too, which is kind of interesting. But I want to kind of go through learning each part. Okay, random integer. Okay, so let's go ahead and let's wire it the way it showed to begin with. And that's what we'll do, okay? All right, so and one of the reasons I did pick this project because it was less wiring than our previous one, which was a doorbell buzzer. Okay, so I'm going to put this over here, give myself a little more room. Usually when I'm working on projects, I actually have music playing. So because of the YouTube stuff, we can't do music playing. But hope you play some music at home while you're following along. Okay, gotta make sure they don't touch, of course. Okay. All right, so let's see if I can match colors they have. My wires may not be long enough. Maybe kind of a jump over here. Okay, so this is going to Gpio 18, and that is going to be the second one. And I need a red. Actually, it's too long. All right, Gpio 17. And then right there. And I got a yellow. Okay, yellow. Going to the middle one. And goes into the 3-volt. Alright, and now I need a blue. And that's going to Gpio 27. Right in the middle here. I will say, usually with the LEDs, and I'm not going to try it with this, of course, but usually with the LEDs, I usually connect it up to the 3 volts of power, and then just plug it straight in to see if it works. But this is interesting because I guess it has, I don't know why it doesn't have to have a ground. That's interesting. Okay, so let's go ahead, and I'm going to go ahead and connect it up. As you see, it'll lay up like that. I'm very sure that's how that's supposed to be, but I want to make a triple check just in case. Very sure. I don't know. Sorry. Here, I'll do this. I'm not doing that. Don't want to make y'all dizzy or anything. Okay, so page 47. All right, there we go. I found it. So we're going to connect up, yeah, just like that, with the USBs down. now that we have that connected, let's go back to our project. Yes, I found out you can just click the table of contents, which is a big help. All right, so let's go. We've wired everything up. And let's get to our code. And we do have an alternative way of wiring, which is interesting that they gave us that. First, observe the project results and then learn more about the code in detail. Okay, and they really do, they give us their email address if we are having problems with the project. Okay, so let's call this Python color filled. Let's go to our me. We will hit new and save. Colorful LED color filled. That's funny. All right, so let's see the best way to do this. The way I've done this before is I then resize this, of course. Don't want it to be too small on the screen, so I'll just kind of go back and forth a little bit. Okay, all right, so import RPI open bracket. Don't think I need a space there, but I'll put it there anyway. Pin red. $11. Pin green. Blue. $13. So we're telling it, make sure, we're telling it which GPIO pin we're going to connect to. And the anytime you see a hashtag, that means we don't have to type that, okay? That's just telling us the notes that we can write down if we want to, okay? Well, you know, it does help if you do write down the right, type in the right number. That might help, okay? All right, so it's saying the pin numbers, the pins are pin red, pin green, and pin blue, okay? Which is interesting because I don't really know. At least in this, it hasn't told me. Maybe it doesn't matter with this. I don't know. We'll have to see. Okay, so let's keep going. Fine. Set up. It should indent. Yep. We're saying the global settings. Green. Gpio set board. See what our notes say. Use physical Gpio numbering. Okay, so that means that we remember earlier I said that, and earlier I said that we may need to use this chart because I do know that these tutorials like to use the pin sets of what the actual numbers are on the board. And that's exactly what it does. So instead of our standard, the ones that we talked about earlier, the graph, where it talked about they're not in order, but this will actually tells us both. Okay, so this little chart will tell us both. And I found a website. Last time I didn't know I had this. Last time I actually found thing that talked about that. Okay, so if you're trying to look that up, say physical Gpio numbering, and it's a website that'll pop right up and tell you. Okay, if you don't have this, okay. All right, so okay. So let's look at that. It says set RGB LED pins to output mode. Okay, I guess that's good. All right, number 11. Make RGB LED pins output high level. Okay. Guess that means crank it up, maybe. All right. Row 12 PWM RED equals GPIO PWM pins bracket pin RED. All right, let me check that. NRE. Yep. I like how it gives suggestions, but it's like I've already typed it and it's still trying to give a suggestion. It's kind of odd. Okay, so Gpio. Oh, need a dot in there, don't we? Gpio.pwm pins. See, pin red, comma 2000. I assume this is about the brightness, or you know what color it is. So it's what it says. It's going to tell us what the different colors are. So it's talking about the different frequency. Okay. All right. So let's do. All right, row 13, PWM, green. Open parentheses. Comma 2000. All right, 14, PWM, blue equals Gpio PWM pins bracket blue. All right, let's kind of look over that. Okay. All right, 15, PWM, green, start. And PWM, blue, start. Now we're on. Give it a little bit. There you go. Oh. What happened? Hold on. Ah, I forgot to do red. Interesting. Okay, we're going to keep it the same order and everything. Start. Let's see, PWM red, PWM start, yay. Okay, now, there we go. And this looks like it's changed duty cycle for 3 pins to the different values. Okay, change duty cycle. Okay. F set. Oh shoot, what did I do? Oh good. Thought I'd like flip to another page there for a second. Have to figure that one out. Okay, so we need to make sure that this is a parent. Underscore see def color RVAL G underscore VAL B underscore VAL. So I guess that's value. That'd be value. Let's see. So set def define. Let me hit save here. Define set color RBG value. Oop, it needs a. I got that backwards. We set color RGB value G value B value. Let's see. PWM red change duty CYCLE R underscore value duty cycle. Let's see, PM underscore value. Okay, so I don't have to retype that 3 times. Oh. All right, and then just change it to green. Change this to G and change this to blue and change this to B. Okay, so let me make sure. All right, so it's save. All right, let's scroll down a little bit. I can't scroll down. Okay, I guess it'll keep going when I get to the bottom, of course. Okay, hit backspace to get over. Hey, Dr. ME, glad you're here. I would probably say middle school at least, or it could be based on what their their interest is. All right, so let's keep going with our project here. And the interesting thing about this is we should be able to make the LED basically any color that we want, okay? And like I said, part of this, and part of the reason we're doing the this, you know, kind of open, I'm working on different projects, is so that we can actually incorporate them into things we do at the library or a new class or something. All right, so let's see. We're going to do random. Okay, so we're going to make it random from 1 to 100. So we're going to make it blink a little bit too. Okay. All right, so let's do, we are now on 24. Let's see, find loop. And we're making a loop, so the while true is a loop. Okay. And it even says get random 1 to 100, set random as a duty value. Okay, so this is going to make it, well, randomly choose what color. Let's see the best way to say that. Well, it's going to make it any color, because it's going to change the RBG value, the green value, the red value, the green value, and the blue value to make up any color that you want. Here it looks like we're going to choose random, so it looks like we're programming it to do like a bunch of random colors, so we'll see. I think at the end of the code it's going to tell us how to more control what the shade of the color is, which will be really cool. So in the past projects, all we've ever done was like turn the LED on and off. And then we did the breathing one where it's kind of going in and out, lighter or darker, on more and off more, lighter, darker, I think. So, all right, so we have our while true, our random, our loop is what we're doing now. Zero to 100. Okay. G equals random 0 to 100. I'm just going to copy that. And change it to blue. All right, so hit save. Let's keep going. Random 1 to 0. Okay. So set color RGB. And let's look at our notes. Set random as a duty cycle value. Psyche. It's a psyche. All right. And then 30 is print. Oh, it's going to give us it on the screen. That's nice. Okay. R equals the percentage. Okay. G equals the percentage. I'm not sure what the D is. Maybe that's telling it. I don't know. We'll have to see. So B equals D open parentheses R. Interesting, there's a space in there. I guess that's for, and then I don't know, I'm doing it exactly as the code they have there. Hopefully that is right. I have worried that you'd get a tutorial and it's like your first time doing it. You follow the tutorial to the letter and then it doesn't work because there's an error in the tutorial and you don't know how to fix it. That would be the worst case scenario. Like, oh no, it doesn't work. It's like, well, I don't know how to fix it because I'm a beginner. That's why. Okay, and and it's going to sleep for a second. So that's only going to go on for 1 second there. Okay, so let's go down to 33. We've got a little more coding just to here, and I think it's going to start, yeah. So basically we just have this one paragraph left, and then we're going to get into actually controlling it and changing what the light will actually be, okay? All right, so 33, get out of that. So define destroy. I think that actually just means stop. Destroy, I don't want to destroy it. No, I think that just means stop. All right, oh. PWM. Okay, so PWM blue, PWM stop, and then we need Gpio cleanup. I guess that would remove the previous, after it stops, it would remove the previous code? I'm not sure. Okay, so now we're on 39, if, and then we're putting the if in here. Name. Does that need a double? I'm not sure. It looks like a double, to be honest, but maybe it's just the font on here. All right, equals, equals, that is a double equals there. I think I might put a double underscore in. Okay, it is showing a double underscore there. So we will see. Okay, underscore, underscore. Yeah, main, underscore, underscore. Not sure if that's a space or not. Okay. We have print. Program is starting. And I have seen this tutorial likes doing that. I guess to let you know that it's working. Save. Print. Program is starting. Set up. Try. Okay, so that's going to give us another indentation. Loop. Okay, so it's going to, and it's telling it to, we actually don't need that because we're using the mu, but we'll do that anyway. We're going to follow it to the T here. So loop. PT. Because we're using the mu, we actually have a button up here that when we, after we click run, we can actually click stop. So we don't have to do the keyboard command of the Control C like we do in the normal Python shell, I guess you'd say. And destroy just means stop. Destroy. All right, so let's go back to our handout here and work on our learning. In the last chapter, we learned how to use Python language to make a pin output PWM. In this project, we output to 3 pins via PWM, and the method is exactly the same as we use. This is what it's talking about, the breathing LED. Method is exactly the same as we used in the last chapter. In the while loop, meaning the loop or the repeat, okay, loop of loop function, the while true is a loop, we first generate 3 random numbers and then specific these 3 random numbers as the PWM value for the 3 pins, which will make the RBG LED produce multiple colors randomly. So let's go back up to our previous chapter. And that was with the breathing LED, okay? So, where's the little thing? So, it's actually talking about it being on and off. Let me see. So, PWM means pulse width modulation. It is a very effective method for using digital signals to control analog circuits. Digital processors cannot directly output analog signal. PWM technology makes it very convenient to achieve this transition of digital to audio signal. PWM technology uses digital pins to send certain frequencies of square values. That is the output of the high level and the low level, which is with our chart right here. So analog, and then here's our digital kind of going up and down. Okay. All right, so let's go back to where we were. All right. We'll make the RBG LED produce multiple colors randomly. Okay, and it points it out what it is. The random function, or random, this function can return a random integer or whole number value within a specific range. Okay, and let's go ahead and try it out. So let me turn, now I'm already assuming, because remember this is the first attempt in learning is fail. So I'm already assuming the first time we try this, we have written the code wrong somewhere. So it should probably give us a few error messages here, and we'll go back through and then check everything. All right, but let's go ahead and hit run. I don't see anything, do you? I don't see anything going on. Okay, so let's look and see. Now, it did not give us any errors in our code. I doubt that we have done it perfect like that. Let's see. All right. It actually did not tell me which way to wire the LED, which I talked about earlier. Oh, it's making me more worried that we're not getting an error message. All right, so let's go back through our learning here. Let's go back to our circuit to begin with. Like I said, when we usually do the circuits with the LEDs. Now, oh, that's right. It did tell us about how if we're not getting anything, we should rewire it to the ground, which is interesting. In this kit, the RBG LED is common a node. The voltage difference between LED will make it work. there is no visible ground. The GPIO ports can also receive current while in output mode. If circuit above does not work, RGB LED may be common cathode. Please try the following wiring. There is no need to modify code for random color. All right, so let's read this one more time. Okay, in this kit, our RGB LED is a common anode. So let me go back to our kit here. We're going to look at our picture. This is a picture of everything that's included with the kit. And I want to make sure, where is it? Yeah, RBG LED. So it says this kit, the RBG is a common anode. So that's the only, let me make sure again. I want to make sure I haven't gotten it confused with some other component that came. No, nothing else looks like that. And nothing else has the 4 legs, I guess you could say. All right, so in this kit, RBG LED is a common anode. The voltage difference between LED make it work. There is no visible ground. The GPIO port can also receive current while in output mode. If the circuit above doesn't work, the RBG LED may be common cathode. So we know that we have this one. So let's go back to our wiring and let's check. And then we'll go back and check our code. It's probably the code, to be honest. All right, so we got our, and I'll have it running, make sure it's running. In case I touch something, all of a sudden it's like, ooh, I decided to come on. All right, so we've got the green. See, this is when it's really good to use the same color that they have. GPIO 18, green GPIO 18. Well, let me, remember I wasn't sure if it should be one way or the other, so we'll plug it in the other way. Aha! Hold on. Got something going on. Look. Let's see. All right, I do have the light is on. Okay. So let's go back to our thing here. But it is always on, so that may not be good. Let's see. Okay, so because we haven't been given any instructions on which direction, if we go back to our, I'm going to assume that maybe the LEDs are similar. So if I go back to our project here, our LED actually shows long leg, short leg. So that may actually be one of our issues. So this is short leg, so long leg to short leg. Well, that would be that way then. I think that's the way we originally had it. Alright, so that's connected. But when I turn it the other way, we do get it to light up. Okay, now we're green. Okay. Sure, nothing's touching that shouldn't. Sorry about that. All right, so I have a feeling that either something isn't connected up properly, so let's try that again. It glowing is a good point, is a good thing. Okay, GPIO 18. Let's see, connecting up to that resistor. Make sure it's the right thing. Yeah. We've got yellow connecting up to our volts of power. So that will turn the LED on and off, of course. 3 volts. 3 volts. And then our red connects to this resistor. Okay, let's play around here. Okay, and then yellow, 3 volts of power. All right. Now, with our code, why is that on just on? Okay, so let's go back to our code. Let's see. All right, so import RBG, the GPIO, import time, import random, our pins equal pin red 11, pin green 12, pin blue 13. Alright, define setup global PWM red, PWM green, PWM blue, GPIO set mode, GPIO board, GPIO setup, pins, GPIO out, GPIO output, pins, GPIO high. Hello, hi, hello. GPIO PWM red, GPIO PWM pins, bracket, red 2000, PMW green equals GPIO PWM pins, bracket, green, PWM blue, GPIO PWM pins, blue 2000, PWM 15 is red start, green start, and let's see. I will tell you this, their code, they've chosen a font to show us in a tutorial that you could possibly confuse the 0 with the O's because they're very close. I'm not saying that's what's going on here. I'm just saying that it's very close. Okay. So set color RGVAL.VAL or PWM red, change duty cycle, RVAL green, RVAL blue, RVAL, define loop, while true, T is capital, R equals random, randint, 100, 0 to 100, 0 to 100, blue, set color, RBG, parent. We never got anything on the screen, which was odd. Time sleep 1. Let's see. Define, destroy, red stop, green stop, blue stop, 37 is cleanup, and if name, this was the one I wasn't sure about. Print, program start, setup, try, loop, accept. So let's see. So let's see, if I'm going to pull up a site here. Let's see, if so while loop. We do have a new thing called try. Let's see, try loop. So I guess that goes back up to define loop. I wish they just had an easy, not a full-on random generated code, just a regular code, basically just to test out the LED to begin with, the wiring. Let's see. I guess with more playing around with it, I could come up with telling it to turn on or not. Let's see, pins red. Well, it is still green. If I tell it this, will it turn off? No, I don't think I'm controlling it right now. I'm not controlling it. It's out of control. Okay, and that's all I get told. Okay, so then it goes to the next part. Okay, what I'm going to do is I'm going to, because I'm not getting an error message on it, so I will actually open the file that they gave us. I have to download it, so just give me a moment. All right, so just give me a moment. I'm going to look and see here if I can. I'm actually going to download from their website the full code. And it is, let's see, FNK 00225. All right. And it is is this they call it colorful? Let me make sure here. Yeah, colorful. So colorful. Okay. Oh, okay. Something's happening. Hold on. Look at that. Okay, but it's only doing green. Okay, so what I did was, okay, so there must be something wrong with the code that let me tell it to stop. There must be something wrong with the code that we did. Let's see. Okay, so hold on. Okay, where's the one that we opened earlier? Okay, so there's our code. We did Python colorful. Okay, so why? So this is their code that came with it. Let's see, 2000. Let's see. It may be something's wrong with the resistors, or maybe I do have the wrong resistors in there. Maybe the only resistor I have that's working properly is maybe the green one. Okay, we'll have to look and see. But still, it means something is wrong. I expected to get an error and then we could actually troubleshoot it, but it not giving me that possibility is interesting. Okay, so if we do run, we can see that it is definitely choosing green. And it is doing something kind of random. Okay, so let's put a stop to that. All right, so we've stopped it completely. And what I'm going to do is this. I'm actually going to because either it's our wiring or maybe the resistors are wrong. But it said for it to be the 220. And my chart says these are the 220. Let's see. Okay, so I think all I have going on is yeah, it's not doing anything with the resistor ones. It's only okay. That resistor's working. Okay, so we know that one's working. So if I switch that resistor out with another one, will it still work? Okay, so yeah, but not very bright, is it? Yeah. Okay, maybe something's wrong with that one. Alright, let's test this one. It does happen. Those must be wrong resistors. They must be. Okay, so if I take one that I know is good and plug it in, we get a very bright light. If I take it and plug it into the blue, okay, nothing from the blue. Okay, if I plug it in there, that works. Let's try the red. Okay, nothing. Oh, nope, it's the wrong one. Nope. Nothing. Okay. it out and I turn it around. Got that plugged in properly. Okay. So we definitely see the output, but why is it only green? Hopefully, oh, okay, I can see. Oh, check that out. Okay. So if I actually unplug from the 3 volts, okay, green. Okay, that's the red, right? Nope. Well, let's see. Okay, red's supposed to be going to the Gpio 17. Yep. And then going to the first one. And yellow goes to the power. And we get a really almost too bright green. Okay. And the green goes to Gpio 18. Doesn't make a lot of sense yet, does it? Okay, so and then one's going to red. To here. Okay. to the end of our time. So we've got a little bit of it working, of course. And I will continue to look into it. If I take that out, aha, look at that. Okay. Now it's like a purple. That's cool. Okay, I think I just got it working. Then what's the deal with this here? This must be green. The schematic says to plug it into the 3 volts. Maybe the schematic is wrong, but it's doing it. Look. It's pretty. We're not seeing the green though. That's the only thing. So maybe the schematic is wrong. Let's see. Undo the blue. Okay, well, I'm calling that a success, even though it's not doing exactly what we had planned it on doing. I have to look around and play around with it a little bit more, but it definitely is. Make sure that y'all can see that. It definitely is changing colors and everything. It's a little bit different on the camera. Looks like it'll even do pink. It's doing a blue, pink right now, a blue. So, not surely 100% sure what the deal with that is, but come to the end of our class, so we're going to go ahead and wrap everything up and stuff. Glad that you're here with me today. Trying out some new stuff is always pretty fun, isn't it? So I look forward to seeing you in my class this afternoon. We'll be doing an internet safety and security at 2:30. So come join me for that. And of course, we have our big class list of all our other classes coming up the month. We'll be doing a fun Scratch game for Thanksgiving and stuff. Got 2 of those going on. And of course, you're getting free ebooks, free audiobooks as well. With Libby, we'll be talking about that later. And look forward to next week and everything too. Again, our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details or call into the library with questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube videos. You can find our YouTube channel by searching YouTube for gchrl.org. And thank you for being here. Hope you enjoyed our little bit of our projects and stuff. Have a great day. Have a safe day. And I'll see you again soon. So bye-bye for now. Bye-bye.